Who am I drinking with? Alone?
What's that?
I'm drinking alone?
No, never.
Okay.
I will drink with you.
Go for it.
This is my first, can I use a mic?
Cheers.
It's my first drink of the day, guys.
Mine also.
Thank you. כן, תודה רבה באמת. It's the last drink of the bottle and my first drink of the day.
Cheers.
בהצלחה.
תודה.
נוסדרוביה. Floor is yours.
Okay. Wow, that was a mistake. Just kidding. Hi, everyone. It's a great honor to be on this stage today, and I really appreciate your presence here. I'm Omer, and in the next 30 minutes, we'll be talking about the web cache deception attack. Web cache deception is a new web attack vector that allows attackers to easily expose the private content of application users, and in certain cases, to even take complete control over their accounts. I discovered it a few months ago in several websites, including PayPal, and as you can see here, by just sending a simple GET request to the PayPal server without adding a session ID or basically any other cookie, you can easily expose the private content of an application user. So just before we begin, let me introduce myself. This is me. My name is Omer Gil. I'm 28 years old, and I'm married plus Java. Now don't worry, you didn't miss a release of a new web framework or something like that, because this is Java. She's our awesome 2-year-old dog. And you probably think now how geek you need to be in order to call your dog after a programming language, right? So that's not so far from the truth, because if I wasn't a geek, I wouldn't have been standing here talking in a geeky conference, talking about a geeky topic in front of a hall full of geeks, right? Yeah, but that's not really the case here, because our Java is not named after the language, but after the coffee beans, of course. Remember her face, because you're going to see her a lot during this talk. For a living, I'm a penetration testing team leader at EY or Ernst & Young. We do penetration tests for web applications, infrastructure, mobile apps, and more. And besides that, I'm a student, just about to have my bachelor's degree in computer science, and that's about me. So we can begin. In order to better understand about how web cache deception works, let's start by explaining two important baselines. So in the first one, we'll be talking about caching. Now we all know about caching. It helps reduce latency from the web server and also to serve the users with their content faster. Now we know that browsers, for example, they do caching. But that's not the kind of caching we're talking about today. What we are talking about are servers that also function as caching mechanism. Now let's see a few forms of this kind of caching mechanism. And for that, you see Java here. She will be our end user. That's a web server, and in the middle, that's a caching mechanism serving this web server, okay? So the first form of a caching mechanism is CDN, okay? Content Delivery Network. That's a distributed network of proxies all over the world. They cache the application's content, and usually the group of proxies that is closest physically to the server, to the end user, which will be the one who will serve him with his content. Now another example, another form of caching mechanism is a load balancer. A load balancer, its main purpose, we all know, is to balance the traffic between more than one server. But it can also cache some of the application's content. And one last example is simply a reverse proxy, okay? Just the front end of the application, which can also cache the content that is sent from the web server to the user. Okay, so we all know about this. Let's see how the process of caching looks like. So let's say that Java here wants to access this static file, stylesheet.css. This is an actual file on a web server. Let's see the process of it. So at first, the request arrives at the caching mechanism. Now, the caching mechanism is not yet familiar with this file, okay? So it asks the web server to send it to him. Now, the web server just sends this file to the caching mechanism, and now the caching mechanism has to decide whether this file should be cached or not. So in order to do that, it has some configuration that someone configured on it. So let's say that the configuration of this caching mechanism is to cache all static files no matter what, because no sensitive or private content could reside inside static files like style sheet, JavaScript, most of the times, images, okay, sometimes. So now when the file arrives at the caching mechanism has to decide what type of file this is. So it looks at the end of the URL, and according to the end of it, to its extension, which is now CSS, it decides that this is a static file and I should cache it. So this file is now cached on the caching mechanism. Now this file is sent to the user's browser, okay? So the next time any user, this one or another one, will try to access this file, the request will arrive at the caching mechanism, and now the caching mechanism is already familiar with this file, right? So we'll just send it back straight to the client without asking it from the web server. Now that's a standard process of caching, and that was the first baseline out of 2. Let's move on to the next. In the next baseline, the second one, we'll be talking about server's reactions. Now the first time I heard of it was in 2 blogs I read about the RPO vulnerability, relative path override attack. It was the spanner and XSS jigsaw. So let's say that this is an actual URL of a web application. There is account.php page, but we don't access this URL, but this URL. We add a slash and then a name of a non-existent file with any extension. So let's see what happens now. So if we try to access this URL, our client, our browser, will send this request as is. It won't be changed. This will arrive at the web server. What's more interesting to look at is how the web server interprets this request. And in certain cases, and not just a few, and we're going to get to concrete examples as the talk continues, the web server will return a 200 OK HTTP response, meaning this URL stays the same with the content of the user's account page. This will be just sent to the user's client. Okay, so I know it's a bit weird, and you're going to see some more examples. So we know that for this weird URL, the content of account.php will be sent from the web server to the client. But what about the HTTP response headers? Will they match the dynamic PHP file or the non-existent CSS file? So as the content, the HTTP response header will also match the dynamic PHP file. You can see an example here for the same URL on a similar browser. Web server, sorry. You can see that the file returned from the web server with a no cache directive matching a dynamic private PHP page. And at the bottom, you can see the content type, which is text HTML and not text CSS, okay? So we've covered the 2 important baselines. Now we can get down to business. Let's talk about the attack and understand how web cache deception works. So here on the right, you can see a web server hosting the web application of Java's bank. Java is my dog, right? You remember that. Okay, so in the middle, you can see a caching mechanism serving this web server, and this caching mechanism is configured to cache all static files. Now, one thing you didn't know about Java here is that Java has a red-haired evil twin. And she's also a hacker, by the way. So one day, this evil twin approaches Java, and she says, "Woof." Now, she's not talking about web application firewalls, okay? Dogs don't do that. They're just dogs. But what it means in English, let me translate this for you, is, "Hey, Java, can you please access the URL of your bank account, okay, bank.com/account.do, / a name of a non-existent file with a static extension, stylesheet.css." Now, Java is an aware user, okay? She doesn't click any link she receives on Facebook. We taught her well, okay? So she takes a good look at this URL, and it doesn't look suspicious at all. Why? This is the domain of her bank account, and it doesn't contain some kind of malicious code, right? It looks totally legit, so she decides to access this link. And let's see what happens now. So Java accesses this link, and a request is sent and arrives to the caching mechanism at first, right? So the caching mechanism is not familiar with this file. So we just send this request to the web server. Now the web server, as we just talked about, returns a 200 OK response, meaning the URL stays the same with the content of Java's bank account, with their own private and sensitive content. Now this is sent back to the caching mechanism. And that's the most interesting part of the web cache deception attack, because now the caching mechanism has to decide whether to cache this file or not. So it looks at the end of the URL, it sees a static extension, and as I said, it's configured to cache all static files, okay? So since it's a CSS file, while it's not really a CSS file, the caching mechanism just caches this file with Java's private and sensitive content, okay, of a bank account. So now this page is cached and is sent to Java's browser, but that's not interesting at all. What's really interesting is that now the evil twin can just access this URL on her own without being authenticated to the website. The caching mechanism receives this request and is now familiar with this file, right? He just cached it. So we just sent it back without asking it from the web server back to the evil twin's browser. Now the evil twin just received a copy of a cached file containing the private content of Java's bank account. It's that simple. And this is how the attack works. Now this is bad, but it could get even worse than that. Let's say that the HTML content contains some CSRF tokens. So now the evil twin can use it in order to attack Java with CSRF. It could get even worse than that. In two web applications that are found to be vulnerable, there's no good reason for that, okay? But the HTML content of the web application contains the user's session ID. So in this case, the evil twin can just take the session ID from the HTML content and take complete control over the user's account. Okay, so now we know how the web cache deception attack works. So let's see a demo of, let's say a demo web application and understand how we can detect over a web application whether it is vulnerable or not. Okay, so I think the video is not working, so let me put it on here. Yeah, it's right here. No, have it here. Okay. Okay, so this is a web application which is hosted on an Apache web server, and it is also served by the Cloudflare CDN for caching. It's open on the left on a Chrome browser and on the right on Firefox. We are now logged out, okay? Now there is a private page in the application called private.php. Each user that accesses this page while logged in can see his own private content. So if we try to access it now, obviously we will be redirected back to the login page, okay? You can see it in both browsers. Now if we try to access a triggering URL, meaning we'll take the content, the URL, sorry, of the private.php page, and we'll add / and a name of a non-existent file with a static extension logo.png, we are redirected to the login page also because this page doesn't exist yet, okay? So now let's log in with the admin account to the web application on the Chrome browser. Okay, now you can see the content of the admin user, okay? That's his own private content. Now let's log in while we are logged in to the triggering URL, meaning we take the URL, we add a / logo.png. Well, PNG, that's the name of a static file, okay? That's a static extension. Now the page is cached on Cloudflare. So if we take this triggering URL and access it on another browser or another device, we just easily expose the content of the private content of the admin user. It's that simple. Let me get back. Okay, where is it? Where is it? עוד אחד? Okay. Okay. This is working. Is it playing? No, I'll turn it on from here. Okay. So a few months ago, I found that PayPal was vulnerable to web cache deception. As you can see here, this is my I'm here logged into PayPal. You can see some private information here, and I just access a triggering URL. I take home, which is an actual page, adding /malicious.css. This page is now cached on Akamai in this case, and now if I try to access it a minute later, a few seconds later, using incognito mode, I just receive a cached version of my private content. Okay? Pretty severe, right? Pretty bad. Okay, so what are the conditions for the web cache deception attack to occur? Okay, so let's see them. So the first condition is that web cache functionality is set for the web application to cache static files based on their extensions, disregarding any caching header. Second condition is that when we access a page like example.com/home.php, which is an actual page on the application, /non-existent.css, which doesn't exist, the web server will return the content of home.php, okay? Last condition is that the victim has to be authenticated while accessing the triggering URL. So after I posted my blog explaining about this vulnerability a few months ago, some people approached me and asked me some why the hell questions. They didn't understand why the hell from the beginning these technologies that we are mentioning here, caching mechanisms or web frameworks, why the hell will they meet these attack conditions? Okay, so I picked up two of my favorite why the hell question, and let's have a look at them. So the first one is why the hell would a web application react like this? Okay, so let's see two examples. So the first one is using Django. So here you see a simple web application I built using Django. You can see there's an actual page called inbox, which presents you this content, the content of your inbox, account, whatever. This is just a standard application. So when you request a resource from a Django application, your request arrives at a dispatcher. The dispatcher is configured inside a file called URLs. So when you want to configure it, you need to use some regular expression to find what you requested in the URL, and according to it, it returns the content that you need to get back to your browser, okay? So here you see a regular expression marked in yellow, which is a standard regular expression used for a Django application. You can see that it looks for inbox at the beginning of the URI, then a trailing slash, and if it finds it, it just returns the content of the inbox page, as you just saw in the last slide. So what happens if we try to access this triggering URL, meaning /inbox, which is an actual page, /test.css, which doesn't exist, while we have this configuration, this regular expression. So in this case, we just receive the content of the inbox page, okay? And why is that? Because look at our URL. The URI starts with inbox, then it has a trailing slash. That's it, we have a match. The regex doesn't need more than that. It just disregards whatever comes next after the trailing slash. And this is kind of awesome for us, right? Not very much for the developers, but for us hackers, right? Okay, so let's see another cool example for Django. Here, I changed the regex a bit. You can see that it looks in the beginning of the URI for the word inbox, but then I removed the trailing slash. So what happens if I try to access /inbox.css? Well, .css doesn't really mean anything, right? That's not really a file. Inbox is actually a file, a page of the application. So in this case, we also receive the content of the inbox page. And why is that? Because our URI begins with inbox. That's it. We have a match. Therefore, we receive the content of the inbox page. It's that simple. So if we want to solve this, we can do it in a pretty simple way. We just need to add one character to our regex. This is the $sign. This is pretty awesome too, right? Okay, so by just adding the $sign for our regex, it will look for a URI that begins with inbox, then a trailing slash, and then a $, meaning the URI should end at this point. So if we try to access this URL, we will receive a 404 error, okay? And now we just solved it by adding the $sign. And why is that? Because our URI indeed starts with inbox. Then we have a trailing slash, but our URI doesn't end here, so we don't have a match for the regex, and we just solve this problem for a Django web application. Let's see another example, ASP.NET. So ASP.NET application has a default, a built-in feature called friendly URLs. Now, friendly URLs, it's a feature that if you try to access this URL, home.spx, you will get a redirection to /home. And for that, you will get the content of the home page. It just removes the extension of the SPX page that you try to access. So you can set this feature, the friendly URLs feature, in a file called root, the root configuration file. Now, by default, this feature is turned on in any ASP.NET application. So let's see what happens if we try to access a triggering URL while this feature is turned on. So in this case, we try to access /account, which is a directory, /manage.spx, which is an actual page on the application, /test.css, which doesn't exist. So in this case, you can see here on the browser that the web application removed the ASPX extension, and we try to access this now. So in this case, the web application received a request for /account, looks for the account directory. Inside it, the web application looks for our managed directory, and inside this, it looks for a file called test.css. But that doesn't exist, and this is why we receive a 404 error. That's a bummer. It seems like we can't attack a user over an ASP.NET application with web cache deception, right? And that's, by the way, makes it very friendly URLs. And now that's for the developers, not for us hackers. So what happens if we take this feature and we set this to off? And I've seen many ASP.NET applications that don't use this feature. They turn it off. So if we try to access the same URL again, you can see that we receive the content of the managed page. Because now the ASPX extension is not removed from our URL, and the web application looks for the account directory, and inside it specifically for manage.aspx page. And once it finds it, it doesn't care what comes next. Test.css, it just disregards it and returns a 200OK response, meaning the URL stays the same with the content of the user's manage page. So that's also fantastic for us, right? Okay, so let's move on to the second why the hell question. And this is, why the hell would a caching mechanism react like this? So let's see 2 examples for that. Let's talk about IIS ARR. ARR, for those who don't know it, application request routing. This is a feature that can make IIS a load balancer, okay? So let's say that IIS ARR is serving some web server that we are using. So for IIS ARR, you can set your own caching rules. And when you set a caching rule, here you can see the edit cache control rule window. We need to look at the way that IIS ARR decides for any file that it receives from the web server, how it decides which type of file this is. So as you can see here at the bottom, it just looks at the end of the URL. And according to the extension at the end of it, decides that in this case, this is a CSS file. And according to this, decides whether to cache it or not. It doesn't go according to the content type HTTP response header, for example, but just according to the end of the URL. So what happens if you try to attack a web application that is served by IIS ARR with this configuration? So let's see an example. So here you can see a triggering URL. samplelab.com/welcome.php, which is an actual page on the application, /test.css, okay, a static extension. This file doesn't exist. So in this case, you can see, if we look at the caching directory on IIS ARR, that a new directory named welcome.php was just created on the caching directory. But that's not really a directory, right? That's a file. So let's step into welcome.php, and we see a new file, a new cached file called test.css. But this file doesn't exist. But you already know what's inside this file. That's the content of the user's welcome.php page. And that's bad, but fantastic for us, right? Okay, so let's see another example. Let's talk about a CDN, and specifically Cloudflare. So I must say a good word about both Cloudflare and Akamai, because they both can meet the web cache deception conditions, okay? But after I posted my blog a few months ago, they both released their own blogs explaining about this vulnerability and also advising how to prevent it. So let's say that we use the Cloudflare services for caching. So in order for a file to be cached on Cloudflare, once a file arrives at the Cloudflare server, in order to be cached, it has to go through 2 phases. Now, the first phase is called the eligibility phase. In this phase, the Cloudflare server looks at the URL of the file that it just received and looks at the end of it for one of the following extensions, static extension. You can see here CSS, JS, some images extensions, Microsoft Office extensions, and a lot more, all usually static extensions. So if our URL will have any of these extensions, will end with any of these extensions, we will move on to step 2. And we already know how we can make the web server return us the content that we want with one of the following extensions, right? So we just move on to step 2. Phase 2 is called the disqualification phase. Now in the disqualification phase, the Cloudflare server now looks at the caching headers that just returned with a file from the web server. Now, as I just talked about at the beginning of this talk, the caching headers of a private page of a triggering URL will probably be with a no cache directive, right? So in this case, the page won't be cached. That's an issue for us if you want to attack someone, right? So exactly for that, we have edge cache expire TTL to the rescue. Now, what is edge cache expire TTL? So about 4 years ago, Cloudflare released a new setting that you can set for your own Cloudflare environment. And they wrote a blog to explain what it does. By the way, Akamai has a similar feature that does pretty much the same. So let's look at the title of this blog. Edge cache expire TTL, easiest way to override any existing headers. Sounds good, right? Let's read more. With cache everything, we respect all headers. If there is any header in place from the server or a CMS solution like WordPress, we will respect it. However, we got many requests from customers who wanted an easy way to override any existing headers. Today, we are releasing a new feature called Edge Cache Expire TTL that does just that. Great. Hey, it's Java. That's good for us. The customers of Cloudflare wanted an easy way to override the caching headers that return from the web server. And exactly for that, we have Edge Cache Expire TTL that can make web server much more vulnerable to web cache deception. OK, so that was our examples. Let's talk about how we prevent this. What is the mitigation of web cache deception? So there are a few options for that. First option is to only cache files if the HTTP caching headers allow. Now, there are good reasons to override the caching headers that return from the web server. For example, CDNs, they recommend you to override the caching headers in order to prevent DDoS, for example. So if you need to use it, then it's OK. You have some other options to prevent it. But if you can avoid it and respect the HTTP headers that your web server return, you probably should. Another option is to store all static files in a designated directory. That will prevent attackers from making the dynamic content of being cached. You can also cache files by their content type and not by the end of the URL. Now, here you depend on the technology of the caching mechanism that you are using, because some caching mechanism, as you just saw, they decide what type of file they just received according to the end of the URL. Some of them do it by the content type HTTP response header. Some of them, like Nginx, for example, let you choose which one do you want to use. So in case you can choose, then do it by the content type HTTP response header. And don't decide what type of file this is according to the end of the URL. One last option is to not accept these kind of URLs. For example, home PHP, which is an actual page, / a non-existent page with this extension, just return a 302 or 404 error instead of that. So about a month from now, I'm going to release a white paper explaining all about this vulnerability, and it will include some more information about additional technologies like caching mechanism or web frameworks that you can look at and see how you can protect your website from being vulnerable to web cache deception. So thank you very much for being here. Have a great evening.